Hello, it's Eric Colburn from ericcolburn.com and Colburn Strategic Partners here again with exercise 4 of the Professional Land Surveyor Learning Center course, DatuGram 3D, working with real data, and we're looking at the approval screen here. So I think this is two parts to this. One is it's a very functional aspect of approving your points and refining the accuracies of what you've drawn. That's always a good thing, and we want surveyors to be actively reviewing their work and making sure that it meets their criteria. But the other thing too is it sort of highlights some of the underlying features of DatuGram 3D that aren't always readily apparent to most surveyors. So what I'm going to do is I'm just going to start with the first point. It was part of a polygon that I created in the last exercise, but the first point that I drew, which was point number 164 in the last video and exercise in the course. We're getting results of about 5/100ths of a foot. As I go to edit this, it might shift it down. So I'm just going to use the search feature and just isolate this one point, number 164, so that we can work with it. So let's look at really functionally what we're doing here a little bit, and then we'll look at the bigger picture and why I think this is really as big of a really feature of a benefit that comes with DatuGram 3D as much as drawing on regular images, which is clearly a revolutionary new paradigm of how to work to be able to draw right on images. Don't get me wrong, that is a great technology. It's what's sexy with the program, but let's show you why that's even more important, that what you're getting out of this software is really more accurate or more redundant measurements than perhaps you've ever done before with topo. So functionally, what are we doing here? So functionally, what we're seeing is the first image on the upper left hand of these tiled images is the point number that, oh, the point numbers, excuse me, is the point that I clicked when I started to draw the polygon for this traffic crosswalk stripe. And then the other images with the green marker are where the software automatically went and found that same pixel, identified it, and what we're seeing on the left-hand side next to the listing of the point number 164, the vertical, horizontal, and vertical accuracies, which are all about 5 to 6/100ths of a foot, which is pretty good for a stripe out in the road. So at some point, the software stopped. So we clicked on one image, or I clicked on one image. It then found it in 6 other images, and it said, I'm getting really accurate results, and it stopped looking. But you can see where there are sort of these little crow's feet. It's located actually in every other image. So it showed up on all 19 images. But again, the software stops. Now, sometimes it'll go a little further. I've seen, when you click on a point, I've seen all the, if it's on all the images, I've seen all, sometimes, all but 1 or 2. It depends really on the quality of the angles and the distance of that point within those images. But in this case, it stopped. We have a total of 7. So functionally, what we can do is, first of all, if we don't like any one of the locations that we clicked where the green marker already is, we can go in and we can click it. I'll move it way over to the side, and you can see the residuals turn red because now it's quite a bit off. So, but we can go in and we can adjust those on the fly, which is very nice. Even this one here, I can sort of see where I'm off a little bit, or the software was off a little bit, I should say. And so we can go in and refine the existing ones, or we can go in to one of the other images and add those points. I'm not going to get particularly crazy here zooming in. I'm just going to eyeball where the corner of that stripe is. Okay, so now it's been located mathematically using the images and the camera information that was developed in the georeferencing. It's on 12 images. So I want you to think about this for a minute. I think this is really the huge feature of DatuGram 3D that often gets overlooked, because being able to draft or draw and measure directly on images is a great thing. But this is, I think, a paradigm changer in of itself. If we were to go out in the field and locate this one corner of the parking stripe like I did by clicking on it, first of all, we'd have to go out in the road, which is dangerous. But second of all, maybe we're taking one angle and distance to that location, or if we're using GPS, maybe it's averaging 3 quick epochs or something like that with the GPS data. But it's a fairly small number of unique measurements to that one point. And if something was wrong on two fronts here, so if something was wrong with the measurement, one angle and one distance, you would never know that it was off unless it was off grossly. Usually, if it's off, a foot, even, maybe at the wrong distance, something happened, or the wrong angle, or if you're using reflectorless, instead of hitting that corner for whatever reason, the angle you were coming in, it hits somewhere else on the other corner or something first, and you don't realize that, or a car or a blade of grass or a branch or anything gets in the way, right? So really, with conventional topography, the way we've been doing it historically, there's very little redundancy built into that. And what we have here is we now have, in this case, we've set it up for 12 redundant measurements. Now, it takes a pair to derive a coordinate. So any one selection in any one image needs another image to get a unique measurement, if you will, as far as the coordinate goes. But for discrete measurements on the images, we now have 12. That's quite a bit more redundancy than we've ever had before. So that's something where I don't really worry myself so much about the accuracies, whether we're getting 3/400ths of a foot or 1/10 of a foot. If I know that I have 12 measurements, or 19 potentially, that's what I could do here. I can go in and I can click on every one of these images, and now I have 19 unique locations and we'll just do that, right? Easy enough to do. 19 unique locations for this one topographic point. So that's all of them now, right? So that's a really big difference in how we verify what our topographic mapping is. Quite often we get asked, how accurate is it? And again, that's a factor of a lot of things: your camera resolution, the accuracy of your initial survey and control work, the distance that, whatever you're clicking on an image is away from where the camera is, and the quality of the angles between the images are important. So there are several factors there that are really important. But like anything, when we're using a measurement system in surveying, when used correctly, you just can't use it willy-nilly. I mean, if I set up a total station, I'm not over the traverse station. I'm not level, I'm not plumb. It could be a highly precise machine. I'm not going to be getting accurate results. But here we have unique measurements. I mean, it could be as little as 3, because that's what's required to extract a point coordinate, or it could be as many as, all the images in your project, which in this case is 19 images. So we have a high level of redundancy on these measured points, and therefore when I look at the accuracy, I'm not particularly worried about what the actual number is that I know it's a reliable number because of the redundancies that's built into it. Now, obviously, if we're coming up with something in 1500ths of a foot or 2/10 of a foot, and it turns, shows being red, then when you do want to filter down through, let's undo the filtering here. We can then filter down, and look at those and see there's some reds and go in and edit those. Oftentimes I find, as I mentioned in the last video, it's because you didn't click initially on a very unique point that's easy to find, or at least the reason it can stay red is it's not easy to define exactly where you click. So when you look at these other images in here in the approved screen, you want to make sure that it's a very clearly understood location, like the corner of the stripe here, so that you can find it in other images so that you can resolve that. And I think I use, here's a good example, the curbing. I specifically, when I clicked on the first image, made sure I was drawing top of curb, that I clicked right where the multiple colors here. Now, if you have a curbing, like a granite curbing or a concrete curbing, that's not a continuous pour concrete curbing, you can zoom in and see where the joint is, either between two sections of a granite curbing or concrete curbing. So, that's a little tip that just will help you in the drawing, and then coming in here and editing through the approved screen to make sure that you have the right locations. But with that said, I think, the other thing is, what do we have conventionally when we're in the field and we turn one angle and one distance, or one GPS shot on a location? As far as describing that location, let's say, actually, let's go back to where we were, because we've actually seen this happen where, what did I do? I went to, let's just filter this by layers, find a good curbing. So this is a good example here where you can clearly see, and I'll zoom in on the post-processing of this video so you can look at it. You can clearly see on the first image I selected the top of curb, and then it found it in all the other images. And let's see, how many did it find it in here? So 17 images. So we have really high redundancy built into this, but I can also clearly see that what I'm drawing is the top of curb. And we have seen where there's been note keeping errors, where maybe somebody says just curbing and you don't know whether it was top of curb or bottom of curb. So this kind of clears that up. This is what I like to call, what you see is what you get drafting. So it's very easy to tell what you're actually drafting versus interpreting field notes, or if they just made a mistake and they located, maybe the person either in a one-man crew on a robotic total station misidentified whether they were locating top or bottom of curb, or more often when you got a two-man crew and one person on either end, either on the pole or on the instrument, is taking notes, and one person's locating the top of curb, but the other person notated the bottom of curb. So as far as the approved screen goes, this has to do with what we're creating new points in the software, but also what I did show you before is we can project the existing survey control. So we'll have a quick word about how much work in the field was really needed to do this, but in this case, they took more shots out in the field than just what they needed to georeference the images. And this isn't a good example. We've seen other examples, but you can just see here, these are parking stripes, but let's just say, or why do I keep calling them parking stripes? Traffic crosswalk stripes. But let's just say this point number 145 was something located in the field about half a foot away, was really the bottom of curb. By overlaying your conventional control points, you can see that. Here's a manhole cover that was located 146. You can see that. So, the approved screen is, the approval process, I think, is really two-step. the approve screen where you can approve what you've created in DatuGram 3D, but also by projecting your survey control and topographic points from the field, you can also do some visual approval of what was located in the field too. I mean, we're talking about very highly accurate results. So if somebody notated top of curb and you can zoom in and you see it's the bottom of curb, we know something's wrong. Or this point number 157, again, is a manhole. If they called it a traffic arrow tip or something stripe, we would know that it was wrong. Really clearly evident that when you're working in DatuGram 3D, that you can go through and verify the accuracy of what was done in the field, and then also approve through the approve screen what was done in your new points when you're creating them. So really, we covered this a lot in the last video, just a brief overview again in this video, but it is really important that you use the approve screen, that you go through, highlight the residuals that this is what I would recommend, highlight the residuals that are red, that you look like there's a problem with the points, make those adjustments there. Red, yellow, green, then I would come down and say, well, what are the important points to me? I mean, I may not care about a stripe in the road being so accurate or not, but as I mentioned in the last video, let's just say I had created a point on the bottom corner of this traffic light, and the height of that, or the elevation of that, was important to me. Then when I get to the approval screen, I want to take those points that I know are very important to me and run through and maybe add more redundant measurements by clicking on all the images that that point shows up in, but also making sure that the automatic finding, automatically found points have been done accurately too. We don't want to just accept what comes out of the machine. The software and the algorithms are very reliable and highly accurate, but we're looking at pixels, and if it's a little bit fuzzy, like this one's not too bad, but you can see some of the other stripe corners are a little fuzzy, that because they're not crisp corners in the field. So if they're not crisp in the field, we add a little bit of a little bit of not being crisp in the images, just because of the distance. Maybe we're farther away from something with a camera, so it's a little fuzzier, right? We have to take that into account. This is a system that is not meant to be black box magic that you just click and whatever comes out of the machine you accept. Go through the approval screen and make sure that everything has worked properly. It does not take you much to filter through it and find the worst results, edit those, and then work your way down towards the most important points. Again, keeping in mind what you're going to be using for accuracies for just general mapping versus what you need for precise measurements for whatever reason, whether that be some sort of an elevation that you need to know exactly what it is or precisely what it is, or something like that, or a coordinate value for a corner of a building, let's say. So work that way, and you'll be really satisfied with your results. Okay, so that's just, again, we've gone over this now really in the last exercise and in this exercise, but again, what I would like you to do is now, whatever you drew in the measure and draw screen, to go through and look at the results in the approve screen, edit those appropriately, look at what was automatically found by the software to make sure that everything worked out okay, but make adjustments if you see that there are small problems. And then if you want to, if you see that you can add other images or other points on other images, go ahead and click on it. Like I say, it's a very quick process and you can do it on the fly. And then look at the accuracies, review what you got for your results, and when you're happy and you're satisfied that it meets your criteria, what we'll do is we'll move on to the view and export screen. There's some reports there we'll be doing in the next section of the DatuGram 3D Working with Real Data course on the Professional Land Surveyor Learning Center at ericcolburn.com/learn. Thank you. Work smart and be brilliant.